Another life about perspective. Perspective. Why is it good to know about perspective? Perspective exists whether you're on a ball earth or a flat earth. If you don't know yet that you're living on a flat earth and you still believe you're living on a spinning ball, even then it's good to know about perspective. Every kid knows the perspective. Every kid that draws, gets into pencil drawing, will sooner or later come across perspective because of drawing. Drawing with pencils. You have a house, for example, and a road, or a city skyline, and then you're drawing that with a vanishing point, creating perspective on a 2D screen, sort of, on a 2D paper. And your eyes are much like a 2D screen. If you close one eye, you have a 2D screen. The only time you actually perceive the world 3D is when you use your second eye, and then both eyes are basically just a 2D perception. Okay? Both eyes together, 3D. One eye alone, 2D. Okay? So it's like one eye. If you close one eye and you just look with that eye into reality, it's like a 2D screen. It's not 3D. We're talking about perception, not reality. Reality is always 3D, of course. But the way you perceive it with your eye, with one eye, is 2D. If you use your second eye, then your brain does something, puts those two times 2D images together and creates a 3D version of it. Okay? But that's important to understand, because one eye is like you're looking at a paper, at a screen. And kids know this, they learn it when they get into pencil drawing. Sooner or later, they come across that vanishing point where they draw a house and a road and like a whole skyline, city skyline or whatever, and use vanishing points to create a perspective on a 2D surface, which is the paper. And that same perspective applies to reality, okay? To your perception when you look into reality. Your eye is like a 2D screen, and it comes with perspective. So things that are further away from you get smaller, things that come closer to you get bigger. At the end of the ground that you're perceiving, let's say you're standing at the ocean and water is still part of the ground, we're considering the ocean part of the ground now, then that ground rises up to your eye level, because there is a point in distance where you cannot perceive that surface anymore due to perspective. And that's the horizon line. Not because the whole ocean vanishes, but like every pixel of that frame, of that camera frame that your eye is, sort of, or has, is vanishing at that point. Okay? And you're just focusing on one point, and everything is coming together in perspective. Like everything that's right from your eye is moving towards that vanishing point in distance. So it's rising up. If it's beneath your eyes, it's rising up to the horizon, and also comes closer to the vanishing point, which is where your eye is centered, what your eye is focused on. Okay? And everything that's left from your eye is also going up towards the horizon and closer to the vanishing point. And that's perspective. And when you did that pencil drawing on a 2D paper, then you know what I'm talking about. You had a vanishing point, and then you had a few buildings, and all the lines of the building had to align with that vanishing point. That's perspective. So when you're standing at a building, at the bottom of this building, of a skyscraper for example, and you see the upper edge, like the roof, it has a flat roof, then that roof, you will perceive it as if it is going down at the end that is further away from you. Okay? That edge that is further away from you from that building seems like it's going down. Because your eye, the observer, is at the bottom of this building. Okay? And these lines, the roof of this building is above your eye, is in high altitude. And so you can take that concept, that theory, and apply it to the sun or the moon. Let's stay with the sun. The sun is just moving on a level, like it's a flat roof up there, and the further it goes away from you, the further it will sink to your perception. Because you're standing at the bottom of this building, sort of, okay? Bottom of this building, then the building goes up into high altitude, and where the sun is, there's the roof of this building. And it's a flat roof. Now, the sun is wandering away from you. The same happens because of perspective. It looks like it's sinking. It's diving down to that vanishing point, to that horizon line. And at some point, it is actually going beyond the horizon line. And people then claim, okay, the Earth must be a ball. Because, hey, look, the sun is moving beyond the horizon. But it's still just happening because of perspective. Why is the sun moving behind the horizon? Because the ocean is material, is the ground, okay, it's a liquid but still material, that is blocking your view up until the horizon line. And that point in space is about 5 kilometers away from you. The horizon line is basically a circumference. You are the center point of the circle, and the horizon is a circumference that has a radius of 5 kilometers. Compared to the vastness of flat Earth, that's nothing. Okay? That's like, I don't know, an ant to us. It's like very, very small on that, it's like a small, small dot on that huge surface of Earth that you're actually perceiving from this ground, from this surface, because you're so close to that ground. Your altitude is just 2 meters maybe. If you're really big, most people are like between 1 or 2 meters of altitude. Okay, if they are just standing at sea level, at the ocean, then you're very, very close to that surface. And the closer you get to the surface, the less you actually see into distance. Okay, if you for example, you kneel down at the ocean, then the circumference of this horizon line is getting shorter. It may be then just 3 kilometers. And now the sun is thousands of kilometers away at the point of sunset. So there's a ratio between the distance from your eye to the horizon line, which is just 5 kilometers, and the distance from your eye to the sun, which is thousands of kilometers. So this creates this whole illusion of the sun diving into the ocean because of parallax, because of perspective, because you're looking at an object that is very far away. If you're moving your eye, for example, up and down, I mean in altitude, your whole body, let's say your whole body can go up and down, then the object that is the most distant from you will almost not move. While objects that come closer to you move a lot because they are much closer to you. So now take that concept again to a horizon line at the ocean and to a sun that you're seeing. The sun is so far away, if you're moving, it makes no difference. However, the horizon line is much closer to you, 5 kilometers. If you're moving, it makes a lot of difference when you're also focusing on the sun. And the way you can compare this is, if you're standing at a skyscraper, at the bottom of a skyscraper, and you're standing at the edge of that skyscraper, and you look up that edge, okay, you look all the way up along that line, now you're focusing on a star. It's nighttime. You're focusing on a star that aligns perfectly with that edge. Now you step to the left from the edge. What will happen? The star will move with you, while the edge will stay where it is, and you will perceive it to the right of you, to the right side of you. And it's gonna look like it's bending. The further it goes upwards into altitude, it's bending towards that star. You see, then the star basically becomes your vanishing point because that star is so far away and the building is much closer to you. So you have a distance relation between objects that are close to you and objects that are far away from you. And that creates parallax, that creates a perspective that must make you understand that a sun, because it's going so far away from you, into distance, can go beyond the horizon line, looking like it's diving into the ocean, looking like the earth is a ball that must be rotating. Okay, but it's a deception, it's an appearance. Don't be deceived by appearances, because in reality the surface is flat. In reality the sun has an altitude, keeps its altitude, but because you're not changing much your location, you just keep standing at that ocean beach, and the sun is moving very far away from you. That's what creates the sunset. It's a visual phenomenon, a visual deception on your eyes, based on distances, based on relations, based on a ratio. Again, from your eye to the horizon line, it's just 5 kilometers. From your eye to the sun, it's thousands of kilometers. Same concept with the edge of the skyscraper and the star that you're focusing on. If you now go down to your knees or down to your belly, what will happen, because the horizon line is much closer to you, then the star, which is the sun that you're focusing on, it will actually put itself between you, your eye, and the sun. Okay? And that's parallax. And when you increase your altitude, let's say the sun has disappeared, you thought, oh, it's going down. You increase the altitude, you can bring back the sun. Okay? Depending on how high you can go. If you can go high enough, you can actually see the sun if it's midnight in your time zone. You just have to go high enough, you'll see the sun. All this because of perspective. That's why, for example, you see satellites in the night sky. They don't have their own light. Okay, they are being highlighted by the sun because of perspective, because they are much higher in altitude. Okay, they reflect sunlight. That's why you're seeing them. If they go lower in altitude or they go further away from the sun, you'll see that they disappear because the sunlight doesn't reach them anymore because of perspective. And that's the same reason why you cannot see Polaris, for example, the North Star, the pole star, around which all the zodiac, all the star constellations turn. That's why you're not seeing Polaris in the southern region, anything beyond the equator. It's just going down because of perspective. Earth does not have to be a ball in order to perceive it the way we're perceiving it. Again, you're so close to that surface of Earth, just a few meters, while there's a macrocosm above your head, the sun, the moon, the stars, and they move in huge distances. It creates this illusion of everything being somehow spherical. Okay? It's just an illusion. If you take an airplane, for example, and you know it has an altitude of 10 kilometers and it's gonna keep its altitude, we know that for a fact. If it's a long distance airplane, it's just gonna keep its altitude. It's flying over your city, over your town, whatever. And you see it nicely these days because there are these chemtrails in the sky, so you can follow them along even if the airplane is not there anymore. I'm not hyping chemtrails, but I think it's very bad what they're doing. But anyway, chemtrails make you see what happens because of perspective. You get a bow shape. All of a sudden you get a bow shape in the sky. That chemtrail makes a bow shape, an arc in the sky. Knowing that the airplane always keeps its level above that surface, you should come to the conclusion, okay, it's actually possible to see the sun the way we're seeing it and just keeps its level above flat Earth. Earth does not have to be a ball in order to get that arc that the sun is making, that the moon is making, that airplanes are making, that the stars are making. That everything makes that is above your head in high altitude. And everything also that would make below your eye level if you could be high enough. You see, if you go very high above Earth's surface, all of a sudden it may look like you're inside of a bowl. Okay? Because the further something is away from you, the more, due to perspective, this arc will be created. Not in reality, not because the Earth is actually bending upwards underneath you. You see what I'm saying? It's not actually a bowl, but you perceive it in this way then. So it's an appearance, don't be deceived by these appearances, and that's something that you can also transpose to people in your life. Don't be deceived by appearances, by how someone dresses, by the jobs they have or whatever. You know, It's very similar to it's just a visual perception, you know. Same with the earth. You live on a flat earth, the way you're perceiving it, you may come to the conclusion earth must be a ball rotating. But it's an illusion, it's a deception, it's just perspective. And actual physics tells us that because of buoyancy, the moon is where it is. Because of buoyancy, the sun is where it is. Because of densities, this equalization of densities. If they were coming down, it's gravity. Okay, if they rise up, it's also gravity. But if they stay there, it's buoyancy. Just like an air balloon or air ball, you know those beach balls, you put air inside, they can float on the water, it's buoyancy. And the same way that beach ball floats on the water, the same way the moon floats in the sky. High up in the sky. And you think, oh, there's nothing, because it's just air, it's just gas, it's just kind of transparent, but to the moon, to the density of the moon, it's something. Okay? If you have a helium balloon, it can rise up, can rise up, can rise up. Through the sky. Until it reaches a level where all the forces are being equalized and it's staying there in this altitude because of buoyancy